everyone, this is Ms. Fazone, and today we're going to be talking about factoring when a equals 1. You may not know what that means yet, but I will explain what a equals 1 means in the slides. Okay, so as a review, let's go through and multiply the following binomials. So pause the video. If you have never seen this before, you should not be watching this video. You should go back and find my video on multiplying binomials. So to multiply this, we usually use the FOIL method, or double. I sometimes call it double distribute. So I need to multiply x by both the terms in the second binomial. So x times x is x squared. X times 5 is 5x. Then I'm going to take my 3 and multiply that by both the terms in the second also. So that's 3 times x is 3x, and 3 times 5 is 15. And then usually we notice that those middle terms go together. X squared plus 8x plus 15. And remember, when you combine like terms, the x's have the same exponent, and you do not change exponents when you add. Same idea for number 2. Multiply. X multiplies this entire binomial. X times x is x squared. X times 4 is 4x. And then we have to do the 7. 7 times x is 7x. And 7 times 4 is 28. So this, again, should be a review. We're going to be using this later on. X squared plus 4x and 7x is 11x plus 28. So that is multiplying those two binomials. So if you didn't write this down, I recommend writing it down because we're going to come back to these examples later. Alright, so what is the general form of a trinomial? Let's see if I have this in here. I thought I did. Okay. So the general form of a trinomial is ax squared plus bx plus c, where a, b, and c are integers, are real numbers, and a cannot equal 0. So today, a can't be 0 because if a was 0, this term would go away, and then we would have bx plus c, and that's not a polynomial, that's a linear equation. So we're talking about trinomials and parabolas. Today, specifically, we're going to be doing these problems where a is 1. So there's no coefficient for x squared. X squared plus bx plus c. So this is the trinomial that we're going to be working with today. If you notice the two examples earlier, that's how they ended up. There was no coefficient in front of x squared. So this is what we're going to be working with. Later on, we'll be doing ones where there's a number in front of x squared. Alright, so in my last video, factoring using GCF, we talked about factoring. There's two things I like to usually say. One definition is writing a polynomial as a product of two other polynomials. So writing a polynomial as a product of two or more other polynomials. I'm just going to write polys because I'm lazy. The other example, the other definition I typically use, just to help students remember what the term factoring means, is it's the reverse distributive property. So reverse distributive property. Math teachers like to teach you how to do something and teach you how to undo it. So you learn to add and then you learn to subtract. You learn to multiply, then you learn to divide. we know how to multiply polynomials. So now we're going to learn how to demultiply them or factor them. Okay? Oops. Did not work. Come on. Oh no. Come on, computer. Here it goes. Okay, so this was our the example we did earlier. So it said, this says, where did the 8 and the 11 come from? So that middle term that we had after we multiplied, where did this number 8 come from? So hopefully you notice that it's because 3 plus 5 is 8. And the 11 came from 4 plus 7. So the 8 and the 11 come from the sum of the two numbers in parentheses. I'll put it like that. So we added up these two numbers. 3 plus 5 is 8. 4 plus 7 is 11. And then the 15 and the 28, where did those come from? Well, again, you should notice that those come from the product. It's 5 times 3 is 15, 7 times 4 is 28. So it's the product of the numbers in parentheses. And this is how we're going to factor. So what we're going to be doing today is I'm going to give you trinomials that look like these, and I want you to write them like this. So we're going to be using this idea that 15 is the product of those numbers, and 8 is the sum of the numbers. Okay? Alright, so x squared plus 9x plus 20, we're going to factor that. So we want to write it as a product. I'm going to write it as a product of two binomials. What has to go in the front of both of those? Well, we want it to multiply to x squared. What multiplies to x squared? X and x. X times x is x squared. Now, we want to figure out what are those two numbers. Now think back to that last slide. Where did the 20 come from? 20 came from the product. So we're looking for two numbers whose product is 20. We're looking for two numbers whose product is 20. And then where did the 9 come from? That's the sum. The sum of 9. So this one hopefully is kind of obvious to you, but here's the method I teach my students. Start with 1 and work your way up under product. There's not a lot of integers that multiply to a number, but some, it could be a million things, negative 20 and positive 29. So start with product. What numbers multiply to 20? 1 times 20, and then I'm going to move up to 2. 2 times 10. 3, does 3 go into 20? No. 4 times 5. And then after 4 comes 5, which I already have. So once I turn myself around, I'm done. So now we're going to add across. We need to find the sum of the numbers. 1 and 20 is 21. 2 and 10 is 12. 4 and 5 is 9. So we were looking for 9. That means this 4 and 5 are my answer. So my answer is x plus 4, x plus 5. If I FOIL, double distribute, multiply that out, I will be left with that answer. And that's it. That's factoring using a table. Alright, same idea. Let's take a minute. So remember, what does that 48 tell us? That the two numbers in parentheses are going to multiply to 48. So we're looking for numbers that multiply to 48, or whose product is 48, and add to 16. So So maybe you think of it off the top of your head, maybe you're not. I always start with writing out what are my numbers that multiply to 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't go into 48, and 6 times 8. Do you see which two numbers add up to 16? Hopefully, it's right here. Right, this is 49, 26, 19, 14. So I was looking for 16, so that tells me my 4 and my 12 are my two numbers. What times itself is x squared? X times x is x squared. Positive 4 and positive 12. 4 plus 12 is 16. 4 times 12 is 48. Alright, pause the video and try this one on your own. Alright, so we're looking for two numbers whose product, I'm going to go back and forth between multiply product because I use multiply in my class, but I know most people use product. So your product is 6 and your sum is 7. So this one should be easy. 1 times 6 and 2 times 3. So x plus 1 and x plus 6. Next one, not so simple. This might throw you off a little bit. We're multiplying, or our product is 72. And we're adding to 38. 1 times 72, 2 times 36. This has a lot, 72, I love giving my class 72 because there's so many numbers that multiply to it. It makes them really think. 18, 6 times 12, 7, 8 times 9. So this has a lot of numbers. So I'm mean, I like to give them ones that they have to think about. So 2 and 36, multiply to 72, add to 38. Write them in your parentheses, don't forget your x. X plus 2 times x plus 36. Remember, the chart or the table is really just to find those two numbers. This is my answer. I've had students in the past, they circle this, they're like, I'm done. It's like, no, you didn't actually factor it. You found two numbers, that's nice, but that's not what I'm looking for. I'm looking for you to write this trinomial as a product. Okay, so now let's throw in some negatives. So it's the same idea, but now my sum is a negative number. So think about what's that going to mean for the problem. So my product and sum. My product is still 18, but this time I'm summing to negative 11. This one sometimes will throw students off. I remember some kids come to me and they say, there's no answer, there's no answer. That's why I like this method, because it should come out. If you did all the math correct, there is an answer. So I see a lot of kids say, oh, 1 and 18 and 3 and 6. But that gives me 9. That can't be the answer. There's another set in there. Think about it. Start with 1, work your way up. Don't forget 2 and 9. A lot of kids will tell me that it's the 3 and 6. They forget about 2 and 9. Okay, now what's the problem? The problem is we're trying to add to a negative. Do you see a negative? No. So how can we turn this 11 to negative? What my general rule is, when the sign is wrong, change the sign of everything. If I make this negative 2, negative 9, negative 2 plus negative 9 is a negative 11, and a negative times a negative is a positive. So this tells you the fact that the middle term is negative and the C term is positive, my two numbers in the parentheses are going to be negatives. So my answer is x minus 2, x minus 9. So when it looks like this, they're both going to be negative. Pause the video, try number 8 on your own. Alright, so this one's actually pretty easy. Our product is 50, and our sum is negative 15. Not that many things multiply to 50. We think in our head it's a decent sized number. There should be a lot, there's not. 1 times 50, 2 times 25, and 5 times 10, and that's it. No other pairs. Which ones add up to 15? My 5 and my 10. Again, I need it to be a negative 15 now. So to turn this into a negative, everything else. Now, does this work? A lot of kids will do this, or they'll make the 10 negative. The problem is, do these multiply to positive 50? They don't, they multiply to negative 50. Also, when you only change one of them, do those now add up to 15? No, negative 5 and 10 is a positive 5. So make sure that both of these become negative, so this still is 15. X minus 5, x minus 10. Alright, next type. Now, what do you notice? We're multiplying to a negative. So this time our product is negative 24, and our sum is negative 2. Start the same exact way we have been. Start with 1 and work your way up. So I have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and then we're back to 6. Okay, so now, do these multiply to a negative? They don't. So I need to figure out, I need to put a negative somewhere. So how many negatives do I need? Only one of them should be negative. So which one? Since the sum is negative, we need the greater number to be negative. So we're going to make the bigger number negative. The bigger number follows the sum, right? If the sum is negative, the bigger number is negative. If the sum is positive, the bigger number is positive. Now we're going to add across. Now notice when we do our sum, 1 plus negative 24 is negative 23. So we're really just subtracting. 2 and negative 12 is negative 10, negative 5, and negative 2. So there's my negative 2. So positive 4 and negative 6. X plus 4, x minus 6. And we're done. This next one tends to throw kids off when they first see it. Our product is simple, negative 30. What's the sum? I see this a lot. Kids tell me, oh, it's negative x. How are two numbers adding to an x? Is 5 plus 6 equal x? While that could be a math term, this is stuff that a younger student should understand. What's the coefficient of x? The coefficient of that negative x is negative 1. Okay. Just as before, 2 times 15, 3 times 10. Does 4 go into 30? No. 5 and 6. And then again, think about, if we're going to a negative number, the bigger number needs to be negative. So I'm making my bigger number negative. And which ones are going to give me negative 1? Right here. X plus 5, x minus 6. And that's factoring where we have two negatives. Hopefully we're almost done. Alright. X squared plus 9x minus 22. Pause the video, try these two on your own. I'm going to go a little faster. We've been doing this a while. So my product is negative 22. My sum is 9. 1 and 22. 2 and 11. So I need to go, this is my 9. So who's going to be negative though? Remember, the bigger number follows the negative. So I want this to be a positive 9. So the 2 has to be negative. So it's a positive 9, x minus 2, x plus 11. All right, 48. Product is 48. Negative 48, sorry. And my sum is positive 2. So 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't work, and 6 times 8. And I know automatically when I have a negative, one of them needs to be I'm really subtracting in my head. So I'm kind of doing this as I go along. I need this to be 47, 22, 13, 8, and 2. I want this to be a positive 2, so which one has to be negative? The smaller number will give me a positive 2. X minus 6 and x plus 8. And that's it. Alright, pause the video and try these on your own. I'm just going to write the answers up. I'm not going to go through all of them because my video is getting really long. Right. Pause the video, try them on your own. Alright, so number 13, I'm looking for two numbers that multiply to 2. What are the only numbers that multiply to 2? 1 and 2. And they do add up to 3. 14, now I'm going to write this one out actually. This one a lot of students get wrong. I get a lot of crazy answers. You're multiplying to negative 6 and adding to negative 5. I get a lot of negative 2, negative 3. Think about why that's wrong. What is negative 2 times negative 3? It's positive 6. I need this to be negative 6. So the answer is actually 1 times 6, where my 6 is negative, right? So be careful with these. There's a few that are pretty tricky, and that's one of them. So my answer is x plus 1, x minus 6. Alright, 24. We're multiplying to 24 and adding to negative 10. 2 times 12 or 4 times 6? Which one is it? Since we're multiplying to a positive number, the signs have to be the same, which means we are adding. So it's got to be your negative 4 and negative 6. X minus 4, x minus 6. Last one. We're multiplying to negative 70 and adding to 3. 10 times 7. It needs to be negative, the 3, so that the 7, so my 3 can be positive. And that is multiplying using a table. Hope this helped. Have a great day.